So this is the second part of the video about this little amplifier module here. In the last one we built all of this, tested the Bluetooth module, seen that it is fairly okay in terms of the waveforms and everything that it puts out, and that this capacitance multiplier here that we put in works really well. So what's left is choosing some speakers, and this is going to be a rather short process because I already have chosen these. These are some fairly cheap Chinese speakers, and I'm running 2 in parallel off of each channel, which works out impedance wise I think quite well, and it sounds pretty good. Also the amplifier is not getting too hot. I've run it for maybe half an hour now and it gets warm. I might glue a little heatsink to this, but it doesn't get hot. And same goes for this regulator and also this transistor. This transistor on the capacitance multiplier is actually the thing that gets the hottest. I also measured the input power here. According to the data sheet, this has a maximum power draw, continuous current draw of about 2.5 amps, which at the 14 volts they say is typical operation, would mean it's dissipating over 30 watts, which I don't think is very likely, given the package this is in, and given the fact that this is a 12 watt amplifier. I'd expect maybe 1.5 amps current draw. It's not going to be 100% efficient if it's really putting out 12 watts, which we don't really want it to do, because if you look at the datasheet, the distortion at the point where it's putting out 12 watts is going to be very significant, like 20% THD or something like that. So I measured this at what I consider is a good listening level with these speakers, and it draws about 1 amp, which is fine. So after I determined this, I chose this transformer here that I had lying around, and this is we zoom in here a little, 13.5 volt 1.6 amp transformer, and you can see this already has a primary side fuse, and it also, I put in a secondary side fuse here, and I have to heat shrink this in. I sometimes do this when I don't want to put in a fuse holder. This should still work perfectly fine as a fuse. The only thing is, it makes it a little harder for you to diagnose if this is blown because you can't see it. But what you can do is you can just measure the resistance between those two windings. And since this is just soldered into two lugs here, you could just unhook one, unsolder one, and then just measure the resistance of the coil. And if it's open, then you know either your transformer is shorted or your fuse is blown, and then you just take off the heat shrink, check the fuse, and replace it. So if you don't expect to change the fuse that often, you can do that. There's also special fuses that have wires already welded to them. Do all that sort of thing, but yeah, it should work fine. Yeah. So for the case, I'll zoom out here, and I'll shove this out of the way. Already printed the case, and it looks like this. And why it has this fabric in here, which I think looks rather nice. If you look at this from the side, I think it looks rather nice. But what I actually wanted to do is I wanted to have a hexagonal pattern here, cutout pattern, but my 3D printer messed this up a lot. So I had to actually cut all of these off. And I went for the glued in fabric instead, which I think it looks rather nice, and it should offer some protection for the speakers. although these are 2-3 euro speakers, so I don't really mind if, if I should poke my finger in there, ruin a speaker, then yeah, I'll just replace it. Ideally, I wouldn't poke my fingers in there, but yeah. So how this is designed is supposed to stand up like this and have the speakers face out to each of the sides. And it basically has the transformer mounted at the bottom here. Give it a nice low center of gravity so you can't easily knock it over. And then the speakers fit into here to the sides like this. And then the circuit board goes in like this onto this little ledge here. And this is a little bit of a loose friction fit, but what I'll just do is I'll put some very strong hot glue on each of these sides. And while I wouldn't do that for something that I produce commercially, for me this is fine, because this is going to stand around, and if I knock it over, it's probably not going to knock loose the hot glue, and even if it does, okay, then the circuit board will wobble around a bit, and I can fix that. Shouldn't be too much of an issue. And also, if I have to go in and repair it, you can, if you only glue it on these corners, you can fairly easily get hot glue off again and fix it that way. So I'd say for something that's, for the use case I'm using this in, it should be perfectly fine. I wouldn't necessarily say it's always fine to do it like that, but it should work. So I'll assemble this now. Oh, the last thing I forgot. This also, I'm going to have a couple of feet down here, because the screws that hold the transformer are going to stick out the bottom, and it wouldn't stand good on a surface if you just have the screw heads poking out like this. So I'm going to just glue some feet to here. So here's the case with all the components stuffed into it. You can see mounted the speakers here, just screwed them in like this. Transformer is also screwed down. The power switch is down here, and this has 2 layers of heat shrink on it, so that you could stick your finger in here while it's running. You have no chance of actually getting a shock under normal circumstances. Power cord comes in back here, goes through a loop, then comes down here to the switch. The speakers I connected to the speaker terminals with these leads that are on there. They're relatively long, and I found it doesn't cause much issues. And the main reason why I just left them that long instead of cutting them to size is, first of all, that way you can pull out the circuit board without getting the speakers out. And second of all, if I ever want to reuse those, it's much easier with the long leads. The circuit board, as I said, is stuck down with this hot glue here. This is this black, really sticky, really strong stuff, which is different from normal hot glue, that it melts a little higher, and it's also really sticky. Instead of, normally if you put some hot glue onto something, you can just easily peel it off. Not with this. This sticks relatively well, although you can still get the circuit board out if you really want to. When you go in under there and just lever it out. The one thing that was missing is a power lid, and I just made one up that has a resistor down here in the heat shrink and is connected to the 5-volt regulator output for this Bluetooth module, and that is eventually going to poke through the front panel like this, or you could put it somewhere here, but that wouldn't look as good. So I think once the front panel is made, we'll just have the LED as a single thing on the front panel, with the switch being on the back side, which is something I like. It's nice out of the way. What I haven't done yet is mount the feet, so I have to print the front panel and the feet, and then this project will be done. Already tried playing some music through it. It sounds really good. Well, it sounds like a 6-watt Bluetooth speaker with not the highest quality speakers on there, but it sounds fine, is what I mean. One last thing, I also had some mercy on this chip and put a heatsink on it, and I stuck it down with this. This is Heatsink Tape, which doesn't cost a lot of money, and it's a double-sided thermal tape, and it's not as good as real heatsink compound, but it also has the added advantage that it's double-sided tape and sticks down really well. So I can't really get this off here. I mean, you can slightly move it if you put some force into it, but under normal circumstances it's not going to fall off if you shake this or anything. And in my experience, once this gets hot and sort of bakes it in, the tape gets a lot stronger. So it's not going to go soft when it's getting hot. It's going to stick down a lot more. And the higher thermal resistance in comparison to like proper heatsink compound glue or something is negligible, because this was doing all right without the heatsink, and now it's just it's a little better. But even if the heatsink would fall off, it'd still be fine. Yeah. So yeah, I think I'll make the front panel and the feet, and then we'll have a shot of the completely completed speakery thing. All right, so here we are with the finished product. Got the switch on the back, power cable coming in like this, speaker cloth, and we've got this front that just has one LED on it, and it's not that bright in person. It's just due to the camera, and you can actually see the light from the Bluetooth module shining through here. If I focus, I'll probably get a lot sharper now. Yeah, so you can also see the hexagon pattern from the infill, which looks kind of nice actually. So yeah, that's the finished speaker. I'm fairly happy with this actually. Sounds good, and it's really compact as compared to the other one, which was almost this size, and then it had two speakers left and right. So pretty happy with how this turned out. Also, it looks really fairly neat inside for the sort of project this is. Oh, also put two feet on it. These are just glued on. And yeah, this is how it stands and works. And so it's due to the transformer sitting on the bottom of it. It's pretty hard to knock over. It's got this low center of gravity, and the part up here basically weighs nothing. So yeah, I'm pretty happy with how this turned out.